Hello everyone and welcome to another Fusion 360 Tech Tuesday. My name is Brad Tallis from Autodesk, and today's topic we're going to be learning how to use parameters to drive changes in a sheet metal part. So you can see here on my screen I've got this blue post, and we're going to create this sheet metal part that goes around it. Now I do have to give a shout out. We actually saw this out on GrabCAD from Sergey Ivanov. So we're basically showing how we would go about creating this particular part inside of Fusion 360. So the next thing I want to show is I just saw this over the weekend and I was absolutely blown away. I'm going to show just a little clip from a company called Fuller Moto, and they are Okay, sorry about I didn't have audio during that clip. I forgot to add my microphone while it's playing a video. My bad. So anyways, that is just a small edited clip of what these guys are doing with Fusion. Definitely go out and check their, we put two links in the description to their YouTube page. It is amazing to see what they're doing with Fusion, and I love seeing what our customers are able to design and make with Fusion 360. And what's really cool in that video, they show different modeling techniques and they show different manufacturing techniques. Okay, I also want to apologize. I was gone all last week on a business trip, so I wanted to thank Jason. He did a really cool live stream on creating like a plastic switch to put over a switch on the wall, so that way kids can't turn on or off particular lights or switches. I thought that was a really neat example. And I also want to give a shout out to Aaron. He did a live stream on what's new in the latest update that we did with Fusion 360. Aaron's helped me out on this live stream, so if you have any questions, throw them out there for him, and let's dive right in. Okay, so we're going to take a look at how we're going to go about creating this particular sheet metal component. And we're going to use parameters to help us design this. So the very first thing I'm going to do, let me make sure, so on my units, I'm going to be in inches in this example. We can kind of see that under the document settings, inches. And then under modify, there's this change parameters. I'm actually going to start with this. Even before we draw anything, I'm going to come into this change parameters, and you'll see that it comes up with favorites, user parameters, and model parameters. And we're going to come back to this a couple times, but what we're going to do here is start with a user parameter. So I'm going to hit the little plus icon here, and this allows us to create a parameter. And in this case, I want to create one called pipe diameter. So I'm just going to call it like pipe underscore DIA, for example. I recommend keeping these as short as possible because you sometimes might have to type them in. So I'm just going to do pipe diameter like so. You can specify the units. So you can see different length units, miles, angles, currency. There's a whole bunch of different formats in here, or units that you could use. But in this case, we're going to leave it set to inch. And then maybe I'm just going to start with, let's just say like a 3-inch pipe diameter. So I'm going to start with a 3 in there. And you can even add a comment, you know, the diameter of the pipe or whatever. When I say OK, we'll see that we now have this user parameter called pipe diameter. And we're going to be able to reference this as we start doing our design. So let's go ahead and start with a new sketch. I'm going to do it on the top plane here. Draw my circle, and I'm going to start right here at the center. Now you'll notice it's asking for a distance or a diameter. So instead of typing in like 3 or 4, I'm going to start typing in pipe. And see, you'll notice even just with the letter P, it finds my user parameter in there. Now, if I had multiple ones like pipe length, pipe hole, or whatever, they would all show up in that list. So all I have to do is just start typing it in, and I'll hit enter, and you'll see how this circle gets a little bit bigger. And instead of a regular dimension, you see this FX. That's a formula. Now what's neat about this is if I came back and let's just do, I'm going to do a quick search for parameters right here. If I came in and changed this from like 3 to 4, you'll see that that will update accordingly. And so you can kind of see already how this is going to become really powerful. If you kind of know what parameters you want, you can drive changes to your sketches and also to you know, your 3D models, for example. So I'm going to leave it at 3. And let's just go ahead and extrude our pipe. So I'm just going to, oops, not offset plane. I want to extrude. And in this example, I'm going to go in both directions or symmetric. And I want the total length. So you'll notice when you set it to symmetric, you get this measurement option. So it's basically saying, for example, if I type in 3, it's going to go 3 inches up and 3 inches down. Or I could say the whole length I want to be a certain distance. So let's just say in this case 6. So now it's the whole length. I'll say OK, and there is my pipe. In fact, doesn't matter that it's a body right now because we're not going to be like doing multiple parts that are moving or anything like that. So I'm just going to leave this as a body. Okay. And maybe I'll change the appearance of it just so it looks a little bit different. Let's just do maybe like anodized blue or something. Okay. So I just hit the A key on my keyboard, A for appearance, to bring up my appearance menu. And then I was able to drag a material onto my part. So now the next thing I want to do is I'm going to switch into sheet metal. And again, I'm using the new user interface. So that's why you see these tabs across the top. So I'm going to click on the sheet metal tab. And the very first thing I want to do is to create a new component. So when you're creating sheet metal parts, you want to make them as components. So I'm going to say new component. And I can give it a name. Let's just call it bracket. And right here, you'll notice it gives us the option to say, is this a sheet metal component? So I'm going to go ahead and click that. And it's going to allow me to specify which material I want to create this out of. And you can see we have some default ones. And then you can see we have some others that I've actually added personally. If you don't know how to do this, I recommend looking at the live stream that I did on sheet metal. I go through in depth how to create your own sheet metal rules. I'll make sure we link that live stream in the description also. So in this case, let's just make it out of 1/8 inch aluminum. I'll say OK. And I now have a new sheet metal component called bracket. And it's basically just like sketching the shape that you want. So I'm going to go ahead and let's sketch on this front face here. Now, if I were to do that, you'd notice that I'm going to be sketching right through the center, and I don't want to do that. Okay? So what I'm going to do instead is use a construction plane. And there's a really cool one in here called tangent plane. And what this is going to allow us to do is to click somewhere on, in fact, I might just go like so. somewhere on the front of this cylinder, and you'll see that it's going to create a plane that is tangent to that cylinder. And you'll see it says 0 degrees. I could drag this around. I could, put it at 45 degrees if I want to. But this is a great way to create a sketch on the outside of a cylinder, for example. So I'll go ahead and say OK. And now I'll create my sketch. And now my sketch is going to be on the, basically the front of this cylinder. Hopefully that makes sense. Okay, so the next thing I'm going to do is just start with a basic shape, the basic rectangle here, and I'm going to do a center rectangle. Again, I hope you know this little tip where I can be out here, I just hit my R key for rectangle, and it shows the different options I have for my rectangles. Same thing, for example, if I hit C for circle, here's all my different circle commands. Instead of having to go under the Create menu, circle, and then, to the one that I want, it's just really quick to be out here, hit my C key, and there we go. Pretty handy. So rectangle, center rectangle, and I'm just going to start here. Now, again, I'm going to reference the parameter that I created. So I want the width of this rectangle to always be the diameter of my pipe. So I'm going to start typing in pipe diameter. And you'll see how that updated. And then I'll do the same thing here. Let's just start typing in pipe diameter. And we can see that it's going to create a rectangle that is always going to be whatever that pipe diameter is going to be. Okay, so the next thing I'm going to do is I want to start creating this geometry over here. And again, we're going to use the variables to help us out with that. So I'm just going to create another rectangle, but I'm going to do this out in space a little bit, just kind of out here. And in this case, I want the overall length of this to be the pipe diameter plus a little bit more. So I'm going to type in pipe diameter plus 1. So it's going to take whatever variable the pipe diameter is. Okay. Oops, I'm trying to move my mouse so you can see it, but it says pipe diameter. And then I say plus 1. So this is a great way, for example, if you needed to add some tolerance or some spacing for something. For example, you want the hole to be 1/4 inch plus a 30/2 of an inch. You might have a variable called hole, and then you could even have a variable called tolerance. And then you would just say, I want it to be hole plus the tolerance. And then maybe you 3D print that or you machine it and it was just a little bit off. Well, then you can come back and tweak that tolerance variable and all of your holes will update accordingly. So neat little tip right there. Okay, so I'm going to make that pipe diameter plus 1. And then I want this, I'm going to leave this, let's just say 2 inches in this case. So I have this rectangle out here in space. But I want it to be centered over here. So I'm going to use my midpoint constraint. So let's go ahead and click on midpoint. I'll click on this line here, and I'm purposely clicking high so you can kind of see how powerful this is. I'm going to click over here, and you'll see that no matter what, it lined up the midpoints of those two lines. So even if this distance were to get larger, this will always stay in the middle of this larger rectangle. I'm going to do that again. I'm going to draw another rectangle, but this time I want it to be pipe diameter with no additional inch or anything like that. So I'm going to just say pipe diameter, and let's just make this 1 inch. Okay, same thing. I'm going to constrain it with a midpoint from there to there. And you can kind of see we now have this particular shape, which is pretty much the exact same shape as you see right here. Okay, so that's what we're creating. Now I could trim a bunch of stuff or whatever, but I'm just going to leave it alone. However, I do want to mirror this down the road. What do I mean by that? Well, I only want to draw half of this. Instead of doing the same thing over here and clicking more edges and more sketches and stuff like that, it's a symmetrical part. So I'm going to split this right down the middle. So I'm going to go ahead and draw a line from there down to here. And you'll see that now there's a profile there and there's a profile over here. But all I really care about is this profile that you see right there. Okay? So I'm pretty much done. We used the variable pipe diameter to specify the size of this big rectangle. We used pipe diameter to specify this length, but we also added in an extra variable, in this case 1 inch. And then we just used standard dimensions for the rest of it. Okay, so now I'm sitting here and I'm just going to select the profile that I want. And we're going to use the flange command in sheet metal. So let's go ahead and click on Create Flange. And what it's going to do is it's going to use the rule that we specified, the 1/8 inch aluminum. I can also specify which side is it extruding from. And if we look at it straight from the top, we'll see that sure enough it's extruding out away from the pole. If I said side 2, it would extrude into the pole, which obviously we don't want. Or I could say symmetric, where it goes both directions. Again, I don't want that. So I'm going to say side 1 and say OK. And there's the start of our sheet metal component. The next thing I want to do is I want to add in this little flange right here that's going to wrap around the pole. This is how we're going to attach this bracket to the pole. And then these open areas you see over here might be like some square tubing that, you know, supports some fencing or something like that. So that's kind of the idea behind this bracket, is it's going to attach to a circular pole, and then it's going to have rectangular poles that come off of it. Okay, so all I have to do is get near this edge. I'm going to pre-select it. Then I'll right mouse click, and around 4 o'clock you can see an option for flange. So instead of having to go up to the menu, I can use what's called our marking menu. So you pre-select something, you right mouse click, and there's the flange command. And I'm going to just start to drag for now. I'm just going to drag a little bit, and we can see how it's going to take that edge, it's going to create the bend relief automatically for me, and it's going to create the bend, and you can see that it's creating this little arm. But again, if we look at the top of it, we can see that it's interfering with our post. And that is because of this bend position. You'll see that it's set to inside. If I change it to outside, it's going to, instead of bending on the inside of this metal, it's going to bend on the outside of it. And you can see now we get the result that we want. Okay. And maybe for the length, or the height in this case, I want it to be whatever pipe diameter is. So again, I'm going to start typing in pipe, and we can see that variable shows up right there. Okay. And you can see how the arm extended to be whatever pipe diameter is. Okay. So I'll go ahead and say OK, and I was easily able to create this arm. Now, one of the things I like to do is I like to make sure and verify that this part is actually manufacturable. What do I mean by that? Well, we're basically using the metal that's in the inside of this opening here. So we're basically cutting out this opening, and then we're bending what's ever on the inside 90 degrees. So I'm going to come in here and say unfold. So under the modify menu, you can see there's that unfold, and it's asking for a stationary entity. What's being held in place? So I'm just going to go ahead and click on that face, and you can see that it actually by default it says unfold all bends. But if I were to, come in here without that checked, I can actually click on that bend, and we can sure enough verify that that tab is being removed or cut out of this opening here, and this would absolutely work. So I just like to verify that. Now, if this were way too long, it would obviously intersect over here, and that's not manufacturable. So it would complain at you. Okay. Okay. Taking a look at my sample model here, you'll see that it has some some round reliefs. And then we're going to do these bends up here, and they have square reliefs. And I'm going to show you how we go about doing that. And we're going to create these little bends right here, these little tabs. So all I have to do is click on this top edge. Again, I'll right mouse click and say flange. Now I could either type in a distance or I could start to drag. Now you'll notice I get a warning or an error down here, failed to compute. Now that's just because when you first start dragging, there's not enough material for it to actually create that bend, and so it's kind of complaining at you until you get far enough, and then you'll notice that the warning goes away. So don't worry too much about that unless it stays there, that it's saying, hey, I physically can't make that. Okay, it's asking for a height. In this case, let's just say 1. We're going to come back to this here in a little bit. And you'll also notice that it's doing the round relief right here. Now, in this case, I want it to be a square relief. And to do that, I can actually come under this override rules. I'll go ahead and click on that. And I don't want to override the bend. This is the actual bend right here. But I do want to override the bend relief, and that's what this is right here. So I'm going to click on bend relief, and you'll see that it says the relief shape is round. Well, I'm going to change it to straight, and you'll see that that turns it to a straight. Or I could even come in here and say make that a tear, and it's going to physically tear that if it needed to. But in this case, we're going to do a straight relief. Okay. So I specified my height of that tab. I've specified my angle. I'm just going to leave everything else alone. We did the bend relief override. Now I'm going to do 2 edges at the same time. So I'm going to hold down my control key. I'm going to go ahead and grab this other edge. It's actually hidden behind, but I can kind of go right through. So I'm going to click on that edge, and you'll see that we can do both arms at the same time. And I'll say, okay. So pretty quickly we created this shape. Now, I could have done this using regular modeling techniques, but man, it would have taken a long time, I think. And I wouldn't have been able to unfold it or create a flat layout to get plasma or laser or water jet. So our sheet metal module, I think, is really, really slick. But what I also think is neat is I can come back and use regular modeling techniques. So for example, I can click on this edge and say, you know what, I want to chamfer that edge. Let's just make it a quarter of an inch, 0.25. And you'll see that it's going to chamfer that edge for me. In fact, I'll go ahead and select all of these edges here. Let's do that edge and that edge also. And you can see how I was able to, in fact, let's go ahead and do all of these sharp edges, because we don't want people, maybe scraping up against it and getting cut. So we're going to soften these edges with a chamfer. I'll say okay. And there you can see my chamfer in the timeline. And just like in regular modeling, you have sheet metal features. You can see all of these features in here. So for example, I could come back and edit that particular flange feature. Okay. Okay, so now we've got the basic shape of it. If I jump back over here, you'll see that there's some holes that go through it. And I'm going to talk about those next. What I'm going to show you here is a pretty neat trick. I like to use this. Now, we have a very powerful hole command, but the trick I'm going to show you, it doesn't really work with the hole command. So we're going to have to take a couple extra steps, but you'll see the power behind it. And what I'm wanting to do is I want to put some holes in here, but I always want them to be centered no matter what this flange distance is. Now, if I were to use the regular hole command, I'll show you an example here. I'll just go ahead and put one there. and I'm going to reference this edge, it's always going to, let's just say 1/4 inch, it's always going to keep this hole 1/4 inch from that edge. But what I want to do is I want to keep it perfectly centered. So I'm going to use a sketch to do this. So let's go ahead and click on that face and right mouse click, and we'll say create sketch. I'll start out by I'm going to draw my circles. I'm going to purposely put them in the wrong spot. But let's just say I want that to be 1/4 inch. And I'll do the same thing over here. I'm just going to draw a circle over here, and I'll make those 1/4 inch. Now I want this to be perfectly centered. So I'm going to draw a line. And you'll notice if I get near this edge, it kind of snaps to that edge. So I'm going to go ahead and click there. And then I'm going to come down here. And notice what's happening here. So you'll notice my angle is set to like 90.2. And that's because it's kind of snapping to this edge. Now I could try and get to 90, okay? Or I purposely do something like this. I'm going to hover onto that edge and click, and it's purposely not straight up and down. I'm going to do the same thing over here. Click and click. Okay. Now you might ask, why am I doing this? Well, I want to force it to be horizontal or vertical. In this case, obviously we want it to be vertical, so I'm going to click on that, and we can see that sure enough, that is vertical. I'll do the same thing there. Now you might say, well, that's a couple extra steps. Couldn't you have just moved your mouse until you got it to 90? Well, the fact that it was kind of sliding along that line, and even though it might have said 90.0, it might have been 90.005 or something like that. Whereas by using a constraint, we are physically saying that has to stay straight up and down. So I like to let the software do the hard work, and down the road, if I got a weird result, it might have been because I didn't force that to be straight up and down. Okay, so I've got these lines. Now I want this circle to be centered on that line. So we're going to use the midpoint constraint. And I'll just say, for example, this line here and that circle there. And you'll see how it brought the circle. And this line is always touching this edge and always touching this edge. So if this edge were to move up, let's say up to here, for example, this circle always has to stay in the center of it. And that's what I think is really kind of cool about this. So you can see that and that. And then finally, I might throw a dimension on here. I'm going to say, I want that line to always be, let's just say 1/2 inch from the edge. Okay? And I'll do the same thing here. I'm going to rotate just a little bit, making sure I'm grabbing that line. And I'll say 1/2 inch. So I spent a little bit of extra time positioning these, but you're going to see the power behind why we did this. Now, I accidentally made a mistake. You'll notice when I go to try and extrude this, it's basically split my profile in half. And that's because I used a solid object line. So I'm going to go back and edit my sketch. I'll select these lines, and these are basically like reference lines. So I'm going to select them and change them to construction lines. You can kind of think of this as like a light pencil line. You just want to kind of reference on your piece of paper this line here, but you want your circle to be the actual object. So I'm going to say construction. We can see how they've turned dashed. And now if I were to try and click my profile, you'll notice how it's not being split by the construction line like it was with the object line. Okay, so I'm going to go ahead and extrude this. And here's another neat little tip. How far do I need to extrude? Well, and I'm actually going to give a shout out. I can't remember who showed this. I think it totally makes sense. I was always saying go through all, and it would go through all of it. Well, you can also say to object. And then, for example, click this bottom face right here, and it's going to extrude to that bottom face. So no matter if that bottom face moves up and down, this extrusion is always going to be touching that bottom face. So that's the to object option. So instead of doing a distance, you'll say to object, and then you just click, for example, that bottom face. And we obviously want to cut, and I'll say OK. Okay, all that work for what? Well, we're going to now add in another variable. So I'm going to come under here and say change parameters. And I want to create, for example, maybe we want to, depending on the diameter of our pipe, we might need to change the thickness of these horizontal bars that are being supported. And so we might have to change how far this flange goes. So I'm going to come in here and say, let's just call it flange distance or something like that. Okay. And what's the expression? Well, let's just say 1.5 in this case. So I'm going to say 1.5 inches. Now, what I need to do is go back to where we created these flanges. So I can come back to, for example, let me go ahead and close this guy out, to this feature right here in my timeline. And here is where we specified the height of 1 inch. Well, instead of that, we're going to start typing in flange, and there's my flange distance. And watch what happens. Notice how it automatically updated. And when I say OK, notice where my holes are. Okay? And again, that's because the line we drew went from this edge to this edge, and we told the circle had to be always in the midpoint. So for example, let's come in here and change the parameters again. Instead of 1.5, let's say 3, for example. And you'll see that flange updates and those holes always stay centered. And I see somebody posted out in the chat, I love parametric design. Yeah, I do too. Here you can really see the power behind this. And I mean, I could even come in here and say, this distance is pipe diameter divided by 3, for example. Okay? And it's going to make that distance whatever pipe diameter is divided by 3. So if we were to change the pipe diameter to like 4, for example, you can kind of see how that mathematically updates. It's pretty cool. I'm going to undo back a little bit. Let me change my parameters. So I'm going to keep that 3. Let's do this. Let's just make that, well, actually 1.5 looks good. Let's do 1.5. Okay. So same thing here. I could create more holes and stuff like that. Let's go ahead and I'm going to go ahead and create a sketch here. I'll do a circle somewhere here. Let's just say 0.25. Okay. And I might throw a distance here. So let's just make that 0.5. And I want this distance maybe to be, let's just say 1. Oh, no, sorry. 0.875. Yeah, let's do 0.875 in this case. And I'll punch that through, or extrude, start to drag. How far? I'm just going to say to object and click on that back face right there. And there we go. Okay. Now here's where I think it gets really, really slick. Check this out. I'm going to unfold. Again, I'm going to do my stationary entity. And you can see how when I click on that, it unfolds all of those things. I can verify that this part's manufacturable. So that looks great. Well, now I want to move this to the other side. So I'm going to switch back to my solid tab and say create mirror. And this just blows me away. The fact that we can do this, and you'll see here in just a moment why I get so excited about this. I'm not even in my sheet metal tab anymore. I'm just in my regular modeling tab, and I want to mirror this component. What's the mirror plane? I'm just going to go ahead and click on maybe this face right there. And you can see we get a preview of what that's going to look like. I'll say OK. And we now have another part, another sheet metal part. So you can see there's my first one and there's my second one. Let's come in here and combine them together. So I'm going to go ahead and say, what's my target? What's the tool? This guy. We want to join them together. We'll say okay. Now you'll notice it still shows this guy here, but if I turn that off, it's really nothing. This is just basically an empty component. It's all right here, okay? We've combined those together using the mirror command. Now if I go back to sheet metal, is it still a sheet metal part? So I'm going to say unfold, click on that, and sure enough it is. So hopefully you're seeing the power, especially on symmetrical parts or complicated parts. You don't have to do a whole bunch of stuff. You can do one area and mirror that over. So I just did the right side, said mirror, combined them together, and boom, we still have a sheet metal part. And here's where it gets fun. If I come in here and say, let's change our parameters. Instead of a 3-inch pipe, I want it to be a 4-inch pipe. And you'll see how everything updated, including the length of the arms here, the length of these guys. So let me go back. Let's go 3. You can kind of see how it's a little bit smaller. I go 4, and it's a little bit larger. Let's go 6, for example. Okay. You can see how big this bracket is compared to the height of my pipe. I think my pipe is only 6 inches tall, but you can see how this arm is updating, or both arms are updating, etc. Let's go smaller. Let's go like 2.5, and you can see how we get a really small bracket. And maybe we're like, okay, the flange is a little bit too long now, so let's just make that 1, and there we go. We can kind of see how those still stay centered. And if I had created a flat layout, if I had created a drawing or whatever, all of this would update, and I can drive my changes using these expressions. So hopefully you found this useful. This is one of my shorter live streams, but I just wanted to give you an idea of what you could do with these parameters. I've shown these before in like some of the woodworking ones that I've done, but think, for example, let's say you're creating a bookshelf. You could create a parameter called plywood that's 0.75 inches thick. And you create all your dado slots, you create all of your parts, and then you go and buy your piece of plywood, and when you actually measure it, it's 0.77 instead of 0.75. Well, then you're like, oh, now I have to update everything. Nope, you just change your variable called plywood, and all of your dados update, all of your plywood updates. It's powerful. So again, thank you for the comments where people like, this is really slick. I appreciate that. Any ideas, throw them in the chat window. My email address I'm going to put in the description here in a couple minutes. I've been having people ask for my email address. I'll absolutely share that with you. If you have anything you want to share with me, projects you've been working on or whatever, I love seeing that. So with that, I hope you have a wonderful rest of your day and hope to see you on a future live stream. Thank you.